So today we are going to study about foundations and footings. At first, rectangular footing. So we can see the cross section, the sectional view and the plan of a rectangular footing. In the sectional elevation, the depth of foundation, the ground level, the leveling codes, everything is being mentioned. So you can see the column, the main steel, the hooping, the starter bars, and where the actual footing lies. We can see the lap slice, length, and the bias diameter. So it's an detailed forecasting of what are the elements that a footing actually contains. The detailing is done with the dowel bars, where we can see the depth of foundation, the lap space, the dowel bars or the starter bars. So these are also called as the starter bars. So total, the sectional view is mentioned and the leveling codes is also being mentioned. The column steel detailing is mentioned here. So we can see there are 3 columns from the top face. The first column contains 4 rods, the second one contains 6 rods, and the third one also contains 6 rods. Isolated footings. So these are provided under each column and may be square, rectangular or circular in plan. The footing may be flat or tapered. So we can see in the picture clearly the meshing is done up to the depth of footing. The footing mesh or reinforcement is done up to the depth of footing. So we can see in the PCC bed, that is in the plain cement concrete, the covering block of thickness is given and the footing is done up to the depth of footing. Square footing. So in the given diagram we can see the top view of a square footing and the sectional elevation of a square footing, where the cross section is being mentioned, the ground level, the leveling codes and the depth of foundation is also maintained. So in the given diagram we can see the different photos of square footing. A rectangular footing. In the given diagram we can see the sectional elevation, the cross section and the plan of a rectangular footing from a top view. The depth of foundation, the ground level and the leveling codes are being mentioned clearly. The detailing is being done. The size of footing, the depth at footing, the depth of footing edge, the nominal and effective cover, the development length, the minimum and maximum steel used, and the spacing of bars and stirrups. So here we can see the different types of piles: wooden piles, non-pre-stressed piles, steel sheet piles, plated box piles, hinge bearing piles, friction piles, part bearing part friction piles, the compaction piles, the tension piles, the skirted granular piles, the under rimmed piles, the batter piles, and the screw pile. Pile cap. The pile cap consists of a rigid, deep, reinforced concrete slab which acts monolithically with a group of piles. The pile should be arranged symmetrically above the axis of the column so that the load from column is distributed uniformly to all the piles. So here you can see a pile cap where the column piles and the pile caps are being mentioned. Pile cap. The pile cap slab is provided of uniform thickness. The pile cap should be extended beyond exterior piles by 10 to 15 cm. The pile should be embedded by at least 15 cm in the pile cap, and the reinforcement in the cap should be placed at least 10 cm above the pile head. The pile cap provided over the entire of piles is considered to be divided into a frame of rectangular beams along which main reinforcement is provided. The arrangement of these beams depends upon the number of piles, and the width of beam is taken equal to the width of the pile. When a column or a pier is supported on one pile only, the column should rest centrally on the pile. However, when the column or any other load carrying structural component is supported on more than one pile, the piles should be connected through a rigid pile cap to distribute the load to the individual piles. Group of piles. Theory and the tests have shown that the total bearing value of Qg of the friction piles, particularly in clay, may be less than the product of the friction bearing value Qf of an individual pile multiplied by the number of piles in a group. However, no reduction due to grouping occurs in the end-bearing piles. For combined end-bearing pile and friction pile, only the load carrying capacity of a group of friction piles is reduced. So here is an example of a pile cap. In this particular photo, we can see all types of footings and foundation.